Hey guys, how's it going? My name is Jersey Ford, I'm Director of Professional Services at Blaze Information Security, like a security company, doing like mostly security consultancy services. But I'm not here to advertise the company. I'm actually here to speak about your handlers, like and how, let's say, this like the forgotten attack surface, how they can be leveraged for mostly client-side exploitation. And here's a quick agenda on the top. So we'll start with a brief introduction of about the URL handlers and how they look like, how to enumerate them. Obviously, speak about some security considerations related to this type of these protocol handlers. Obviously, show practical exploitation like POC or the account, and finally conclude it all. And now let's speak about that. Just mentioned before. So basically, I guess all of you know what your handlers are. So for example, when you go to Pirate Bay, all of your movies, and then there is like a magnet link. So when you click there, and then like magnet and then some stuff there, when you click it pops like pop up saying that hey, like this is a BitTorrent client, click here, and after you click, it spawns a BitTorrent client, and it starts downloading the movie that you want to watch. But they're like roughly, like just from a Windows point of view, there are roughly two different types of them. They're like application and the portable ones. So the portable ones are not really scope on the top, so essentially are the ones that when you type HTTP something or FTP : or file : these are handled by the browser itself. So these are not the ones that we're talking about. What we're interested about are the application handlers. Are the ones that when something happens, in the case, for example, the BitTorrent client will spawn an actual external program, and then we'll see how we can actually leverage this kind of behavior to create some exploits. Actually, I forgot to mention that obviously they are supported by the most popular operating systems, Linux, Windows, and macOS. Like I don't like Macs and I don't have one, so there is absolutely nothing related to Mac in this particular presentation. However, they can be also a security threat for Mac based environments. So protocol handlers, obviously they must be registered. Like so, that's the thing. Like many people don't know they even exist. Sometimes like install like any program on your computer, and in many cases the program already registers these handlers on your behalf, and you don't even know about. But yeah, we'll see later about that. But it's going to register itself in the Windows registry. Like in the case of Windows, again, like the Windows system registry, for example, or like in Linux, something very different, but there will be directly there. And before it can be called. But if you say, for example, contextual column // well, there is no handle with his name, the browser will say, hey, I don't know what to do with this. Sometimes, in many cases, actually with latest browsers, you will just straight Google that particular thing, you will just go for a search engine. But if the handler actually exists, it will pop up something. Sometimes it doesn't even pop up, depending on what it is, or depending if you have agreed to it before to use it and kind of properly if you use it anymore. It will just spawn whatever program it's supposed to. And the thing is, this creates a bridge between like one application can call the other. Like we speak about people like browsers, but then other applications like a messenger application and some native applications can also have this same ability to call these external programs. But the good thing is, like, if an application has a locally exploitable issue, and you think that okay, it's only exploitable like locally, you can actually, as you can call this from this case, the context we're talking about here, the browser. This means this can actually become exploitable remotely because of this, say, bridge that it creates. And because of that, well, obviously makes things a whole lot more interesting. So as we see here, like browser will actually do that application. What I just mentioned before, like if you have a big torrent or like and that colon slash slash developments, what it does is the operating system it will map this big torrent thing into you will go to the registries of the Windows event and see like, oh yeah, I actually know this handler, and this is the program that I should call whenever I see this handler. And in this case, just let's an example here, like maps to product.exe. And this is later we'll call respond the program, BitTorrent and so on with these arguments here, like quotes. It's actually important to them. So far, everybody understood what's happening? Any questions? Maybe somebody outside. So this is like an overall process of more or less how it works, and then we'll see later how we can actually leverage this into our advantage as an app. How do they look like, and how to enumerate them? So this is like how we're gonna start the presentation now. So I think it's okay to read, right? So this is like your Windows registry again. Like Mirk, actually, who is old enough to remember Mirk? That was like actually pretty good. So it says here that like whenever it sees Mirk, it should call Mirk itself with this %1. So anything that goes IRC colon slash slash and anything after that, that's considered the argument that should be requested here in this %1. So what happens here when you call, say, IRC colon slash slash irc.fnet.org, we will spawn IRC here with these arguments. So this is like this scene is in Process Explorer. So we can actually see how when the program was launched, all the options or like the information that we need to inspect them. So as we can see here, these actually the %1 was substituted for any what was there. And then we're going to be say, hey, like I was supposed to connect the website before, but I'm being asked to connect that FNAT, so it means that it actually works. So whenever we saw that, we understood that this is an instruction that it should fall. So it means that again, like we can actually call external programs from like the host browser. How to find them? Because of Windows, the handles are registered in this particular keys here, like hclass, like ht class root, / new program. And there's like a few interesting values. So there is this like a ZT value here. URL protocol is one of them, and default. So URL protocol will have like in the case of here, it will be IRC. So whenever it is IRC, it knows what is not that URL handle is registered. And also the command to respawn will be in this particular key here. So in Linux, like I'm speaking about Ubuntu, like actually the one I use. Well, it's not that I use it so much, but the one that I have not yet actually. There's the command line parameter, this is how you can actually find it. You can list all these things with grep. And it's a file something about desktop, so this is like a command that you can actually use to enumerate all of them that are in your Linux. Now let's see a quick demo on how to find them in Windows. So like I wrote like a small Python tool called try-reg. You have to do the same to enumerate automatically. This from Windows, so like every time say install something, if you run it again, most likely you're going to see some new URL handlers that you actually were not even aware of. So just install a few software install. So this is actually important to keep an eye on this app surface that in many cases is completely unaware of. So let's have a look through. Actually, something about things. This is small. So it says that I found this So it's not missing things. Like the output's horrible. I'm working on actually improving this. But yeah, really, I'll do it at some point. But at least it serves the purpose of listing all of them, and I can see like what are the protocols, what does it call, and how it's being called. Because we're gonna see later. That's the way that sometimes these arguments here, for example, this 12% one and so on, that depends on, sometimes it gets completely messed up and becomes even more insecure from, like, we're gonna see later. And now, obviously, let's speak about some security considerations around them. So, like, first and foremost, it's very important to say that nothing that I'm speaking about here is actually new. I would say that it's been at least 15 years that these issues are well known, very well understood. However, they're still around. Like, I still found stuff like this year in software, like in Java, for example. And stuff like this we're gonna see later. And especially this is all the rage lately. There was like an issue with Electron, you know, gonna see shortly afterwards, like it was from last year. That pretty much every Electron app was vulnerable to this kind of not every Electron app, obviously the one that the relationship itself in an interactive fashion, they were vulnerable. So even though these things have been around for like some 15 years, I mean they're still here. It's not like other classes of bugs that kind of disappeared. I know this is like a bit Windows-centric, like what I'm speaking here, but it again applies to other operation systems as well. So yeah, like in the case of Windows-centric too, like untrusted data will be passed into shell execute, like to spawn the execute was supposed to and this proper sanitization. And in many cases, this actually doesn't really happen. And because of that, you can take advantage of it. And Microsoft gives this explicit heads up about security issues. There is an MSDN topic on for developers that if you're planning to write software and register your own custom handlers, please be aware of such and such and this and that security considerations. But yeah, sometimes people will overlook any sort of security recommendation. So now let's move on to more interesting things. So yeah, when you're assessing protocol handlers, there are like a few things, interesting things to observe. So whenever you, like for example, processes for process monitor can be very helpful here. So when you call spawn software, the executable, it's important to like keep an eye on a few things like how it interacts with the file system, how it does with whatever arguments passed to it, if there's any network connections going on, and so on. And this behavior, like sometimes like for this behavior is fairly insecure, you can actually take advantage of that for your own purposes. Also, this is actually super important, like interesting command switches. So sometimes, like, yeah, fine, you can just spawn process, but nothing super important there. But there is sometimes some switches like, I don't know, delete file or create file, and then you can actually create a file somewhere in an arbitrary location file system to do that. So also knowing the arguments that the application is expecting is a very important thing to know how you're going to exploit this. Moving on, there is like now let's see like some well-known, probably registered handler. This is the case of Skype. Skype, if you see here, there was a dash before this %1 within codes. You guys know why? Nobody has any idea? So basically, the dash, it will just instruct that anything here, if it comes with another dash, something like a command line switch, it will just be ignored. It will not be taken into consideration as a command line switch. So it means that, like, it's not going to be another flag or something, right? So you will just ignore whatever next arguments you may want to do this. So yeah, Skype did well. Probably it would be way back in 2005. But yeah, since then I hope that they can introduce this again from the version. Some handle that kind of incorrectly registered, like in the case of like Amazon workspaces. There is just like a quote here and the percent one. This is incorrectly registered. However, exploitation will be dependent on the browser, for example, that you have, or like all the browsers actually behave like hardly with this, and it was easier to at least break out scopes and actually potentially introduce other arguments. But yeah, again, like whether we find an interesting online switch that we can take advantage of, that's a completely fun story. And now we go from here. At least this was a version from here from May, I think, from this year. This has absolutely nothing. And this is the most insecure one because you can pass absolutely everything. There's no need to break out the quotes because we know later how some browsers behave. And some browsers will code the quotes and so on, so you can actually calculate pass the elements that we want. However, this one here is still exploitable. I mean, not mirror. They patched this particular issue, but any software that registers handle it in this way and has any interesting switch, this is still exploitable with modern developers. That's also like super important to mention some previous research on this area. It's not again, it's not new. I think this is like the most important work that was done like in URL user groups Black Hat 2007. So again, this is like pretty old, even though it's still around. This guy is probably not even security industry anymore. Like from now on, it's like some findings from long ago. More recently, it happened about 2017, so it's like 10 years difference from one to another. It was still like a very interesting talk from this Chinese hacker called Red Rain on this particular topic. And more recently, ZDI had this 0 as well. It was this guy that found a bunch of bugs in some EA software games. And also ZDI that had like very interesting blog posts on this particular topic. Again, as I mentioned, the one that vulnerability is affecting a bunch of Electron apps. So in the case of Electron, there was this very interesting switch. There was like -- GPU launcher, and if you put -- GPU launcher, say calc.exe, it will just pop the calculator. So if you could do this break from the browser into like include the quotes and so on, and all you could just like execute commands on the client side. This was patched half-assedly, so they patched with a blacklist. But the blacklist was wrong because it was put like GPU launcher, but like as capitals, and it would still print. So they had to patch it again. But since then, I think there was no bypass for it. Qt-based apps. So if you have an application, like a native application that's based on Qt, Qt has some interesting, it has some interesting command line switches that they still there in Qt, although it's part of the function of the whole thing. And some of them are pretty interesting unless you have your Qt application compiled statically. They will look for DLLs and so on. And in the case here, there is like this very important one here, platform proving path. That this one you can set the proving path that's going to load DLLs from. And in this particular case, we're going to see later how to exploit that. So pretty much every Qt app that's not has the switch by default. Whether it's your switch from your app or not, this is something that comes with Qt. If the app's compiled with Qt and uses it, this switch is probably even unaware of it. And also this one that we call the booger and so on. There's also this one for Qt Web Engine. But the platform proving path is the one that I have exploited things with. So after the blog post from ZDI from last year, or actually this year, so there was a guy that said, hey, this platform these may cause problems, which I agree. However, it's something that's expected. But then the guys from Qt, which is like one of the guys presume as well, he says it's not our bad. This is like your app is already broken for that. which I agree with, but maybe they could do something to improve QT-based applications to avoid developers shooting themselves in the foot, like with an extra safety net. But seems like they're not going to do it anytime soon, and well, that's good news for us at least. Again, like some variable software, the best, like pretty much everything, like mobile scopes, right? What happened here? Okay. So more recently, this Exodus wallet, it was a very decent one. More advice, it was like enterprise, we're going to see later who concept of that. Here, we just mentioned, we're also going to see the concept of how to have like remote code execution on client side, and a bunch of other things, really, like how a lot of software have been played with this software related in the past. So now, let's speak about some practical explanation of software. So if you have a URL handler, let's say as test, and register itself as easy as executable and the quotes and set one. So if you call again test dash colon and whatever argument, it will just call this executable.exe with that particular argument, right? So yeah, this is the argument that we have here, the parameter and so on. This was going to be strong within quotes. Yes, but it doesn't mean that like if we pass this malicious, let's say this is a malicious parameter and some argument, it's still not going to be interpreted by the OS as an extra switch. But what if we break the locals, right? This is how it's going to be spawned. And this is going to be treated as an extra argument. And again, we have to rely on the fact that this extra argument is something that we can take advantage of. Everybody actually understood this one? All good? So this is like a sequence injection. You can actually just introduce something else from quotes with that. But anyhow, let's see like now how modern browsers behave. So how it works quotes in spaces. So if you put like say test colon something or break the quotes and put double quotes there and put spaces, it's now encoding. It turns into %22, %20 respectively. However, it was encoded from September 2011 to November 2017. So like for 6 years, it was exploitable and nobody knows. Firefox, it encodes quotes, but it does not encode space. I don't understand this because space is not a valid, space is not a valid part of the URL, right? There's no such thing as URL with space. So you probably should move into that. Internet Explorer and Edge, since July, for the real data lake, it has copied the behavior of Chrome, but then there is still a lot of people using like from legacy systems and some government offices, they still use some old versions of IE, and this is totally horrible. So yeah, this is like the ticket from the web tracker of Chrome. Yeah, this is like something from 2017. It said, there was a regression. They introduced this thing. In 2011, we only noticed it now. Yeah, sorry, for 6 years, everybody was learning to that. Now let's see how it actually built like a modern Chrome. If you see here, we call it without parameters, but you can see here %2, %20. So we cannot really check anything that's meaningful that we would like to we could explore. This is how. Which is the same thing. Right. With Firefox, you see that Firefox doesn't go to spaces. So, we're calling it with spaces and see here it's not anything, there should be. It doesn't do it. So, even the latest version of Firefox doesn't do it. This is Firefox with the quotes. We have a quote here. And it says the important quotes. So, yeah, it's going to be harder to break out quotes with Firefox. The older IEs doesn't encode shit. Right? Everything's just here. But the latest version from July, it's copying the exact same behavior of Chrome. So now let's see a few proof of concepts here. So I hope it's gonna work. Like Demo is always that nerve-wracking part of the presentation. I didn't record any videos or anything. So let's just hope it's gonna work. So I'm gonna open this on Firefox so that it's actually the latest one. Oh yeah, okay, cool. It's saying I'm trying to let's see the source. So the source says that I'm calling. So by the way, this record was not discovered by myself, but like some guys from France, I think, discovered it in May this year. So I'm just using this as a proof of concept, but it's like I'm not claiming credits for discovering this issue. So what happens here is like I'm passing again the Firefox space -I. This is reads a different configuration file, reading either react.me. I'm using here my own computer, but this can work on UFC path. So if you put the // and some share, it will just load and load the window. That's that. Let's go back to the concept. So let's open it. Again, if somebody has clicked on my choice, this one will just go straight. So, if you continue, takes a lot as well as the demo version. So, there's that evaluation of the using anyway. This was a very easy. So, now when we continue, it will not pick up later because it turns out that we go. So we actually went to this configuration file that we just set maliciously, and the configuration file says, hey, by the way, when you load up, you just run this command, please. And you can just, for example, instead of compilator, you can do your own PowerShell malicious thing. So cool, I'm glad it actually worked. Alright, so let's move on to the other. The other one's full malwarebytes. So malwarebytes is an antivirus from, I don't know who uses this, but in the case of malwarebytes, this is a Qt-based application. This is actually the payload. In the case of malwarebytes here, this is again, we're breaking the codes, we're putting this platform on the path, and then this where we start to go and look into this directory. Again, we use a single share for that, so we can exploit this remotely. From my experience of exploiting these Qt apps, the applications that I compile statically, they don't have any need to go and fetch for extra DLLs. So bummer, doesn't really work. Maybe it does, but I was just not clever enough to figure out how to do it. But how to analyze this thing, for those applications that are not suddenly compiled, we just run application under process monitor and see what's loading up in terms of DLLs. So there's a bunch of default DLLs that Qt will use, like the platform DLLs, the Q Windows DLL, Q something else DLL, or Q JPEG DLL for the JPEG rendering engine, and a bunch of other things. So the idea is run this thing under process monitor, see which DLLs it's looking for, and then I got the DLL that we're looking for, I got the original one, put it into MS Venom from Metasploit, and then generated my malicious payload, so inject my malicious payload within the DLL, and then that's how I created this positive version of the DLL, and then we're going to store it somewhere for it. However, as you saw before, the latest browsers won't. This particular one, at least with the three big browsers, is going to be complicated. So I'm just gonna use another version of Internet Explorer to show you guys this issue. So as you see here, it's actually not including anything, right? That's what this works. Yeah, okay, cool. So again, it will fetch the DLL, that the resolution wants like a big pop-up layer, could be like a shell style. And then, we have another demo. This I claim that was actually legal from this. It was a bug in Java JRE. Actually, it was a feature, though that could be exploited. So essentially, there's this Java web stacker or something, web launcher, yeah, the JP files. So, actually, so this one here, basically, it's called it's gonna fetch something from the internet from any URL you want. However, those like the NS, something URL connected, something from Java that essentially, if you try to fetch any resources from a particular web server, if your web server was challenging it with the NTLM challenge, like, hey, you will just have to give out the hashes without asking anybody. And this is why I have so I have this product here, and then I'm gonna try to. I hope you're not actually watching the features. We'll say like I'm able to launch the application and so on. But if you see here, it just gave all the hashes. Like happily without saying, without even asking, like somebody's trying to challenge it or anything like that. So now, let's wrap up the talk, conclude this. So, this custom URL handlers, they're very overlooked, freely overlooked at surface. This kind of bugs are still around. You still can find them in 2019, surprisingly. And they're probably going to be here for 2020 as well. And let's have fun with them. And fixing is usually easy. You just have to be aware that this kind of issue exists. And tweak like things in registry or how you register itself within the operating system. Browsers have made things harder, but how about mobile desktop native apps? I don't know. I haven't really investigated. Maybe it's an exercise for you guys. And that's pretty much it. We'll make a bunch of references for this talk, and it's time for questions now. Thank you. Could you use this sure. Actually, it's great. Good observation. There's something I forgot to mention. Yes, because you can call the external program, right, and pass it parameters. If, like, for example, one parameter is overflow, format strings, or anything else, yes, if you can call it, because you essentially bridging, right, like from remote to local, so you actually calling the application with whatever makes you want. Yes, this is the case. Buffer flow is totally. There was actually a bug in Trillian. Trillian is like a really old messenger from the mid 2000s that was vulnerable to it. It was just Trillian, like column, whatever arguments the thing would just like exploit straight up and step in buffer flow back end. But yeah, so pretty much everything. But if you can. As if you're like as if you're writing terminal, pretty much when you as you can reach these two things. Any more questions? Is it possible to type output of one application to another one, like just concatenating another application that actually you want to call? Not really, because at least in Windows. I'm not sure because this is all spawned with shell and Zec API, and it's not like system the like API, like system it's different. So it's not that it's calling a shell and doing this for shell. It's like exact view or something. It's slightly different. At least from my observations. I may be wrong, but from what I have seen, you cannot really call it pipe and like or the angle brackets and stuff like that. Yeah, you know what I'm talking about. I haven't really seen it working when I tried. But maybe wrong.
So I'm just going to questions. One thing you already mentioned, the potential attack surface on platforms. So you haven't looked at that at all? Well, I was
not at all.
I'm just asking you because I've noticed a lot of applications on mobile platforms that just only work for that. So it's like really rich harvest there.
No, yeah, that's true. I don't think I have seen any research even from all the people in this case. But then many mobile applications they're like mostly like Electron or something, or so Electron uses Chromium. So I don't know if I really don't know. It's something that needs to be looked into.
The other question that I have is, but I think you already pretty much answered that. Because you were saying that different browsers include different, special characters like space and slashes and so forth. Have you looked into potential effect of things such as carriage return 90? Carriage return 90, zero A.
There was an issue like that with many years ago in Windows. It was actually the way shell exec was behaving when it was seeing these characters.
Mm-hmm.
So Microsoft had to issue it was actually a critical patch back then because this made pretty much even if your URL handler was fine, almost everything was important because of that.
Yeah, okay, so that's already a good example.
So yeah, I think maybe some regression again, you never know.
But in terms of attack vectors, like you ask this only via like instant messaging, emails, something like that.
Yeah, this is the client side.
Right. Of course, but you still gotta get someone to like invoke.
No, yeah, you need someone to at least click on this thing. Right. Or at least I've never really seen it in a very automatic fashion. Every time I've seen this, it's usually pretty much you can actually, for example, if you have cross-site scripting somewhere, you can actually, this is an iPhone, it's cross-site scripting, like iframe, blah, blah, and then it will just form. So it still can be more automatic way. There will be still a degree of user interaction though. Yeah. Well, thank you.